of a silly thing. What we want to do is grab it once and be done with it. Furthermore, it'd also be a good idea if we actually check to make sure there was actually a character controller on our character. So one thing we're going to do, we're going to take character controller and we're going to create a little placeholder for it. We're going to move this over here. And so we're going to grab it and store it there. And then anywhere we need the character controller there. So now we're no longer looking up the character controller every single frame. We're only doing it once. We can also check here, you know, if this happens to be equal to null, right? Or to put it more succinctly, if not character controller, I'm not sure you can do that in C#. I think you do actually have to check for nullness. If it's not there, then, you know, freak out and say, hey, well, there's no character controller on me. What's up with that? Of course, in Unity, you can handle that preemptively by doing a require component type of character controller, like so, and that will actually raise a compiler side error if there's no character controller on the object. Also, if I take this script and drop it onto an object like a player, it will automatically add a character controller component for me. So that handles a lot of the stuff for me, and I don't have to freak out too much. So slightly more optimized there. And yeah, I think that's all we have to add to the the first-person controller in terms of movement. Let's look at the chat again for some questions. The next thing we're going to look at is shooting. Or no, actually, I'm going to look at some lighting stuff first, and then we're going to look at shooting. I know some people keep asking about things like sprinting and crouching. I addressed crouching already, in that what you would do is you would take your character controller and just reduce the height and bring it down, and also just lower the height of the camera, and that way you'll be able to duck under geometry just fine. Sprinting is, you know, you can just do something like here where we're multiplying our movement speed. You could just add it to another check, you know, if the sprint key is held down, then your movement speed is, you know, multiplied by like another, I don't know, 1.5 or something like that, you know, like whatever your game logic is supposed to be. That's all it takes for sprinting. And if, you know, you're only supposed to be able to sprint for a certain amount of time, then, you know, every frame that the sprint key is held down, you're ticking down some sort of reserve fuel, and then when you release it, the fuel, your energy, your stamina recharges. Very easy sort of bookkeeping to implement that sort of thing. People want more sofas. Yes, if we switch get button down to get button, it will enable bunny hopping. So let's give it a try. Some people would prefer that, right? It's as easy as that. That will return true every frame that space is being held down. Null reference exception. Is it the character controller? What did I forget to test before I moved on here? Oh. Right here, I'm creating a new variable and storing it in there. I'm never actually populating the class member. There we go. Now we're good. Right, but I changed that so it's not bunny hopping right now. There you go. Just show off the bunny hopping. I think the jump is a little too anti-gravity. I'm going to move back to a speed of 5. I think it's just going to be a more reasonable jump height. So I'm just holding down space, bunny hopping. You know, there's nothing wrong with that, if people prefer that sort of thing. I don't know how first-person shooters tend to handle the jumping these days. I don't think that bunny hopping is generally turned on in modern or in more recent FPSs, but I may be wrong. I don't play that many of them. All right, let's check here. Any other questions? Yeah, in this game, you're quite literally cameraman, kind of. I mean, you sort of are in all the FPSs, up until the point you start shooting. There was a first-person game that was made once that was about being a cameraman in a war zone. I don't remember the name of it, but it was really dramatic. Okay, I want to take a second to talk about lighting because obviously our level looks quite boring right now. We just have the one light in here to make it distinct. If we delete that, then everything is one big muddy, gray, uninteresting piece of garbage. And we can see our scene again if we do something like a textured wire, and that will sort of vaguely help. So we want lighting. Now, lighting is a really complicated issue in games because lighting, just like in photography, lighting makes everything. Beautiful lighting will make a game just stupendously good. The problem is that human beings, our brains, are really wired to understand how lighting should work. And when it doesn't look quite right, we can tell. We might not be able to tell what's wrong, but we can tell, and it really, really throws us off. And that's a big problem. Things like shadows, right? But then there's these subtle things. In 3D renderers and games and stuff, they've got this thing called global illumination. But the idea is, if I take, let's see, I will take my mining helmet. Let me switch the camera over. Make it big. Camera. There we go. So if I take my mining helmet here, and I take this roll of paper towel. I mean, it might not be obvious in this setup, but just say. The white light that I've got positioned over here is bouncing off of the helmet, so it's illuminating this, and it's also illuminating the tube. But the thing is that some of the light bounces off of this and will get put onto the tube. Now I can see it when I'm looking here. The side of the tube that's near the mining helmet is slightly orange, maybe more yellowy. I don't think it's going to show up on camera, but there's that sort of reflection, and that sort of thing is basically impossible to do in real time because it involves so many calculations. You got to follow all these light signals. It just doesn't work, and that's one of the weaknesses in a lot of games. And one of the things you can do when you're pre-rendering things. Like you're making a Pixar movie, or you're making the Transformers movie. When you're pre-rendering it ahead of time, you don't care if it takes 1,000 hours to calculate all this like reflective light, as long as it looks good. So you just let your computer bank of 1,000 computers sit for 1,000 hours, calculating all the bounced lights, and that's great. You can't do that live in a computer game. There is a certain amount of pre-calculation you can do. Shadows is another really hard thing to do in real time because it's just very, very complex. But most importantly, there's also per pixel lighting. We're going to run into some problems here. I'm going to demonstrate a case that shows off some of the issues that you will have playing with lighting for the first time. And you won't understand why it's happening and why it's looking stupid, and you're going to get frustrated. I know I have many, many times. I'm going to create a point light here. I'm going to set it just 3 meters above the surface. I'm going to stick one right over here. So, I mean, that looks good. Let me turn off the textured wire. So, I mean, this light seems to be behaving basically the way that it should be. There's no shadows yet. There's nothing like that. But, you can see the sort of halo of it on the ground. It's lighting all that. It's fading off. The further away you get from the light, the less it gets. I can move the light around. And, you can see the light source move. And that's great. That looks good. If one's good, a second one's got to be good too, right? Yeah, that looks good. And a third one, nice. And a fourth one, nice. And a fifth one, and a sixth one, and... Wait a minute. Are you noticing that there's no pixel lighting? Oh, but then all of a sudden there is. And I'll zoom out and all of a sudden there's not. And why is that happening? Why does it look all stupid all of a sudden? And in fact, my old one over here isn't being lit. Oh, now it is, now it's not. What's going on? There's a limit to the number of lights you can have in a scene that do something called pixel lighting, which is what the pixel lighting is, that the really nice lighting that you're seeing on these flat surfaces. They can still do vertex lighting, and if you want to know what vertex lighting is, well, I will intentionally go to my project settings, my quality settings, and I will turn off all the pixel lights. Now, none of these lights are pixel lights. They only do vertex lighting. So the lighting is still kind of there. But you can notice if you get in really close. Again, I don't know if this will show up properly on the stream, but you can actually see where the polygons are from the different triangles. They sort of highlight a little bit. And some of this effect could be minimized if I used a higher polygon count in my models. But it's still not quite right. And basically, vertex lighting, it's lighting just the corners and then sort of extrapolating from that. Whereas in pixel lighting, if I bring that back up, it's doing a much more complicated pass to get a better looking light. But it's got to do a full render for each light that's affecting it. So if you've got one light affecting the object, it's doing a more complicated render already. But if you've got a second light, for example, you've got one that's red and one that's green, right? And let me pull back up. Let me delete the extra lights so that we actually have the effect happening. Like all of a sudden it already looks good. You see there's the green light, there's the red light. In the middle here you've actually got a yellow bit where the light's combining in the way that it should. And that's awesome, but it means that the whole geometry is actually getting rendered twice and then they're getting blended together. So if you go into Unity and you go into your quality settings, and you can change how many pixel lights are allowed. In fact, the fantastic quality is automatically set to be 4 pixel lights. And if you've got a really good video card, you can go higher and higher and higher and higher. And you know, maybe you can do some sort of sophisticated auto detection. Maybe you can ask your user, how many pixel lights does your video card support? I don't know how many pixel light my video card supports. So that can be an issue, because what if you want a really cool lit scene with all these kind of fancy ass lights? Well, the limit only applies to real-time lighting. So again, we've got here, I'm on Fantastic, so I can get all 4 working properly, but as soon as I make another duplicate and stick them over here, things start to fall apart, because that's not pixel lighting, that's vertex lighting, and it looks like crap over here. It looks good over here, looks like crap over here. If these lights aren't moving, and if the geometry, if my actual level itself doesn't move, and it doesn't, right? The level is static, the lights are static. I can pre-calculate all this crap ahead of time and have lots of beautiful, wonderful lighting that works stupendously well, but has been pre-calculated. So we're going to do that. I'm going to create, you know what, we're going to do it. We're going to be organized. We're going to create an empty game object. I'm going to bring it to 0, 0, 0. I'm going to call this static objects. These are going to be all the objects in my game that don't move. And I'm going to create another one. We'll leave the dynamic one separate. So I'm going to take my cubes here. They're static objects. I'm going to take all my lights. They're all static. They don't move. I'm going to take the level geometry itself and stick it under static object as well. And I'm going to take this whole parent thing. I'm going to hit this static flag. And yes, I want to change all children to be static. Right? So if I click on any of these, they've all got this little static flag checked off. So that does 2 things for us. The first thing is it actually helps hint to Blender that these objects won't move, so it can do certain rendering optimizations by pre-calculating certain things in terms of what will you be able to see at any given moment. But the second thing it allows us to do is start using light mapping. Now, light mapping is where Blender in the editor will go through, calculate all my lights, all my static objects, and figure out how the lighting is supposed to work. And when you're in game, it's actually going to turn off the lights. And all this stuff that is being calculated in real time right now is actually just going to be a texture that gets applied to our surfaces. Transparently, you have no idea it's happening. It will just look like the lights are perfect, even though it's not really being calculated in real time. It's a cute trick, and a lot of programming are these cute tricks. So I'm going to go ahead and hit this Bake Scene button. There's a really good chance this is going to kill the recording or kill the stream, because this is going to explode my CPU while it calculates all this. I'm pretty sure I have everything set up right. Do I have these turned on to do shadows? Oh, no, I want shadows. Let's select all the lights. We're going to turn on soft shadows everywhere. And I'm going to make sure that in my actual quality settings, I'm going to stay on Fantastic, but I'm going to make sure my shadows are disabled. There's going to be no real-time shadows enabled. And if you're working on the free version of Unity, that wouldn't, you will never have real-time shadows. But this will still work. So yeah, they're all set up to cast shadows, which is good. Let's go back to light mapping. So I'm going to hit the Bake Scene button. Let's wait. Let's see what happens to the computer. This probably will take, I don't know, 30 seconds. Grind, 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 grind. The more stuff you have, the more lights you have, the longer it will take. There we go. Saving out the data. In the list of things that aren't supposed to happen, that was one of them. Generate lightmap UVs? Baking again. Work this time. Come on. Come to daddy. Yay! Okay. So, in our model, we need to tell Blender to generate some light map coordinates, basically, for our stuff. And you can tweak how that works, you know, for angles and hardness and things, but we'll just leave it at default by now. But now if we take a look at our scene, in fact, we'll go in first person mode. And we got some lighting. I mean, it's terrible lighting because I've got terrible settings. I mean, blue or green, red lights. What is this, like the Christmas simulator? But, you know, it's there. All the lights are working. If these were not baked in, these lights, half these lights wouldn't be working properly. They wouldn't be real time. Stream still working? I think so. I hope so. Because they wouldn't be pixel lights, right? They would try their best on vertex lighting, but that would be it. So now they're all working. And not only that, but you notice here on the floor, there's a shadow being cast. It's actually a very low resolution shadow, and I could turn that up dramatically. I don't think it's going to matter much for the stream or the recording, but just to show you where you would do it in with the light mapping selected. Grab all your lights, or you know, any light that matters, but we'll say we'll grab all of them. And over here in shadow samples, you can turn that up, and you can turn it up to like 50, 100, something like that. It will dramatically smooth out your shadows. And if you increase the shadow radius, it will stop it from being a hard edge. So if I just turned up the shadow samples right now, the shadows would be this hard, super clean edge, and they already kind of are. This one almost looks like it's floating a little just because of the intersection. Yeah, it's these sort of sloppy edges, and it's very, very muddy actually. So if I turned up the shadow samples, it would make this look much, much better. I'm not going to do it for the video because it's not important, and it would take a little bit longer. But yeah, it would really define it. But if you don't set a shadow radius, it would be a perfectly straight line shadow. And in reality, shadows don't really do that because your light doesn't come from a single point in space. It comes from a sort of object that is glowing. And so your shadow, you're kind of getting like multiple shadows that kind of overlap. So you get this like blurred, soft shadow edge. It looks quite lovely. So you want to, in practice, A, increase this like so, and B, increase the shadow radius. If you increase the shadow radius without increasing the samples, it's really not going to look right. You're going to get all these little like kind of dots all over that aren't going to work well. But there we go. So we've got that. I'm gonna turn this back down because again, I just don't want to render that'll take too long when I upgrade that. So there we go. So that's not, I mean, it's not great lighting. It looks like stupid Christmas stuff. So let's take all those lights. We'll, I don't know, turn them to white. See, it doesn't update my scene either because these are no longer real-time lights. We're going to have to rebake everything. We'll turn down the intensity. There we go. We'll turn down the intensity because they're just going to be too much. We're going to have a lot of lights in there. So now if I retake this and rebake the scene, it should look a lot less stupid. Doop, 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 doop. There we are. So, I mean, we're back to just white lighting, which isn't necessarily exciting, but it looks pretty good. And again, we've got those shadows. However, you may have noticed this ball is not casting a shadow. And the reason is this ball was not marked as static because it moves, right? If I'd marked it as static, then we'd see the ball shadow, say, right around here, right? because it starts off at the top of this ramp. So we'd see a ball shadow here, but the shadow would still be there even after the ball rolled around. So for these sorts of objects, you need real-time shadows to make them cast shadows. It's hard on the CPU, or most likely the GPU. There's real limits to how many lights you can practically have casting real-time shadows, and it is a feature of Pro Unity only. So you got to know your limitations. Now you can fake these sorts of shadows quite easily with a blob projector. We'll look at that. I'd have to pull that in as one of the standard assets. You know what? Let's do it. We want light flares. I think it's under light flares. I am wrong. I guess I should have canceled that. Light cookies, perhaps? That's not right either. What is the package? Projectors! See, as soon as I see it, I know for sure. Okay, so the blob shadow projector is what we want on our sphere, for example. I think that will work just as is. There we go, and we want to tweak it slightly. You can see what it does. It's not a real shadow. It's basically the same as like, imagine it's a black light, a light that projects blackness, and it's aiming straight down. So it's kind of like a pixel shader. It's not really light or anything, but it's there. We can move it up a little just to make the shadow size a little bit better. We can make it go wider. Yes, no, maybe so. I guess we can just bring it up and then change the near clipping plane, because you can see it's projecting onto the top of the ball now, which is not what we want. So we can change the near clipping plane, there we go, to be inside the ball. And now if we hit play, there should be, oh, it rotates with the ball. That's not what I wanted. Can we not, it doesn't represent a difficult problem to resolve. I thought it was built in, though, that it would always face down. I guess we'd have to put in some extra scripting or something like that. Yeah, that would just keep this locally, or keep it in world coordinates always rotated down. And then you would have a nice shadow on the bottom of the ball all the time, no matter where it rolled around. So that's the way to fake shadows, is to use these blobs. Obviously, it works great on anything that doesn't rotate by itself, and apparently anything that does rotate, you'll have to make just a little bit of extra work, but there we have it. So let's get rid of the shadow blob projector anyway, because apparently it doesn't work right. But that's how you fake real-time shadows, and that's all you need. The biggest thing with those shadows, like under the ball, because right now you're not sure, is it hovering a few centimeters above the table, the surface? You can't tell, like you can't tell if it's aligned, whereas that blob gives you a real sense of context as to where the ball is on top of the surface. And that's going to be good enough for most games. Most games, that's all they do. They have a little light shadow. In fact, that one's quite dark. We don't even need anything quite that dark, but you tune it for your game. Any questions about lighting before we move on to the shooting? And the reason I wanted to do the lighting first is because the shooting, while an actual simple bullet effect, is whatever, we're going to want to make it look cool, and that means cool lighting effects when we have explosions and things. Yeah, that's weird. I did change the title. It apparently didn't stick. What the hell? I hate Twitch, because when you change what you're playing and you're not live, it doesn't take. That is so annoying, because I changed it before I started, but apparently I've got to go live, change it, go unlive, and then go live again, or some stupid thing like that. What a pain in the ass. Shadow Simulator 2013. Rolling Ball Simulator, yes. How do you add objectives and missions to your game world? That's an excellent point, and we will certainly look into doing something like that. The problem is there's no one answer to that. It's just sort of a programming thing. The biggest thing, objects will have to do something. They'll have to send some signals. It's entirely through scripting. If you just want something to happen when you walk into a zone, what we can do is something like, we can create, for example, let's say we create a cube, right? We'll make this cube quite large, and we're going to stick it let's say this is the room where you finish in and you win, right? So we're going to take this and then let's make it big enough so it covers the whole room. All right, we're going to do this. Now this comes with a collider. There we are. So when something bumps into this box, we can have a script attached to it that responds to that collision. And specifically, we can check if it's a player